Lesson 5.9, solving problems with exponents and logarithms. So this is the last lesson in this chapter. So Charles Richter, the Richter scale, right? He defined magnitude. So we're talking about earthquakes here, and it's really interesting when you get into earthquakes. It's all based on a formula, m equals log I over s, right? So m is the magnitude of the earthquake, I measures the intensity of the vibration, and s represents the intensity of a standard earthquake, which can barely be detected. Okay, so let's look at the example here. So we have two earthquakes. Earthquake 1 is classified magnitude 5. Earthquake 2 is classified magnitude 7. Oh, you're thinking, well, that's just 2 times as big. Well, no, because it's based on logs when it has to talk about intensity. So let's look at the first question. Determine the intensity of the first earthquake in terms of a standard earthquake. So here we go. So m equals log I over s. So we plug in the 5, log 10 of 10 I over s. Well, how do we do this? Well, we change this to exponential. So there it is, 10 to the 5 equals I over s. How do we get I by itself? Times both sides by s. So that first earthquake is 10 to the 5 times as strong as a standard earthquake. Okay, let's do the same thing for the earthquake 2, which has a magnitude of 7. So we work through all this and we find out, oh yeah, it's 10 to the 7, right? So earthquake 2 is 10 to the 7 times stronger than a standard earthquake. Okay, so part 3 or part C here, how many times more intense was the second earthquake? So it's not 2 times. Oh, look here. 10 to the 7 divided by 10 to the 5. Same base, we're dividing, so we subtract our exponents. 10 to the 2. So if you go from a magnitude of 5 to a magnitude of 7, that earthquake is 100 times as strong, right? So as it goes up, it does way more damage. Okay, so flip the page and let's talk about pH, alkaline, and acidity. Again, it's all based on logs. So acidity of a solution is measured using the logarithmic scale called the pH scale. So a solution of pH of 7 is considered to be neutral. So if you look at this list here, you can see 7 neutral right in the middle, right? For each increase of 1 pH, the solution is 10 times more alkaline. For each decrease, the solution is 10 times more acidic. So it's all base 10. So what we got is we got ammonia and we got seawater. So if you look on here, where would ammonia be? Oh, way down the bottom here. Seawater, oh, right about there. You can see where it is in there. So we do the same thing again. So what we want to know is which sample is more alkaline? Well, the ammonia is more alkaline. Why is it the ammonia more alkaline? Because it's further down the scale here, increasing this way. How many times as alkaline is the sample? Okay, so we do that. 10 to the 11.5, 10 to the 8.4. Where did these numbers come from? That's the pH scale. And again, same base, we're dividing, so what do we do with the exponents? We subtract, so we end up with 10 to the 3.1. Calculate that out. It's almost 1,300 times, right, as alkaline. So it's all base 10, it's all logarithmic. Okay, last page. This example is actually from one of the provincial exams. And you can see it's a calculator part. It has a little calculator up the top here, so you'll be able to use your calculator for this one. And again, oh, look at this. They're talking about compound interest. And sometimes when they do compound interest, they give you different formulas, but they will always define it. So what we want is how many monthly investments of $50 would have to be deposited into a savings account that pays 3% annual, compounded monthly, which means it's earning interest every month and put back in, for the account's future value to be $50,000. So looking for your future here. So the formula is FV, future value, R, the investment amount, I is the interest, which is the annual interest rate divided by the number of compounding periods, and N is the number of investments. Okay, so here we go. Here's the formula here. So we want 50,000 as a future value. We're going to put in $50, right, every time. The rare is the rate, compounded monthly, that's the 12. We don't know the N. Oh boy. So look at that, that's buried in there. We got to be able to solve this. And then I down the bottom here again is the rate by the compounds again. So you simplify as much as you can. So 50,000 equals 50. What did we do here? We took 0.03 divided by 12. We got this number. 0.03 divided by 12. We got this number. Okay. Now, how do we go from this to here? Well, look, is there a 50 in here? Yeah. So get rid of it. Divide both sides by 50. So 50,000 divided by 50, and the 50 goes here. Oh, I reduced it down even more. Then, how do we get rid of this 0.0025? You multiply both sides by that amount. Oh, look, that gets rid of that. That goes from 1,000 down to 2.5. It's getting simpler and simpler as we go along. How do we get rid of this -1? You add 1 to both sides. So 3.5 equals 1.0025n. Now, can't solve that. Different bases. I wish there was a way we could do that. Yeah, you can actually log both sides. Now, this question will work whether you use log or whether you use natural log, ln. You will get the same answer. And if you don't believe me, try it. So what we do is we log both sides. We take the n, which is the exponent, we bring it down the front, which is our rules of logs, and then we try to get n by itself. So how do you get rid of this log of 1.0025? You divide both sides by log of 1.0025. So there it is, e equals n. Now, you're thinking, well, I can't do this. Well, if you look back up the top there, if you notice, this is the calculator section. So for part of the provincial exam, you will be able to use your calculator, and this is one of the ones you'll do it. So you do that, you figure out what n is, and then you have to, if you look, don't leave your answer as 501.7. The question is said, and you got to pay attention to that, express your answer as a whole number. Okay, so how many times? 502, right? You got to be careful of that. You always got to look at what the question asks. Okay, so that is 5.9, which is your last lesson in this chapter. We're going to start on Unit 6 right away.